Michael Powell asks, explain what universal time is and talk about what weird happens when you mix different time systems. Well, Michael, what I mean by universal time is UTC that you mentioned. What time is it is a simple question. Unfortunately, the answer is complex and nuanced. What the question actually asks is, how much time has elapsed since a widely agreed upon event? The widely agreed upon event is referred to as the epoch. In the Gregorian calendar, the Western calendar adopted by both the United Nations and the Universal Postal Union, the epoch for the common year is a religious event calculated to have happened more than 2012 years ago in this year AD 2013. The AD is from the Latin Anno Domini, meaning year of our Lord. The referenced epoch isn't even correct. Modern calculations place the birth of Jesus of Nazareth between 6 and 4 BC. Most Unix-based systems use an internal epoch of January 1st, 1970 at 12 a.m. This internal epoch is translated to whatever the local time is. Converting time between different referenced epochs is conceptually a simple translation, adding the difference between the two referenced epochs. Only it is not so simple. The calendar and sundial were created to match astronomical events. These events are not perfectly regular. The advent of atomic clocks showed that the length of an astronomical year is slowing. Leap seconds are occasionally inserted to keep the universal time coordinate, formerly Greenwich Mean Time, aligned with the astronomical year. GPS time does not use leap seconds, a simplifying assumption to position calculations based on the time of propagation for a signal. There is currently a 16-second difference between GPS time and UTC. Astronomers use sidereal time, synchronized precisely to certain fixed stars. This greatly aids in accurately pointing their telescopes. Let's talk about time zones. Prior to accurate mechanical clocks, localities observed apparent solar time. Essentially, noon was when the sun was most directly overhead. The following paragraph is directly from the Wikipedia article on time zones. Most of the time zones on land are offset from Coordinated Universal Time, UTC, by a whole number of hours, from UTC minus 12 to UTC plus 14. But a few are offset by 30 or 45 minutes. Some higher latitude countries use daylight savings time for part of the year, typically changing clocks by an hour. Many land time zones are skewed toward the west of the corresponding nautical time zones. This also creates a permanent daylight savings time effect. What time zone and area observes is a political, not a technical decision. It is governed by national, regional, and sometimes local laws. Time zones do not even remain consistent from year to year. We experienced this in the US when President Bush extended daylight saving time in an attempt to conserve energy. The state of Indiana has gone through 7 legislative time zone changes. Let's see if I can pull that up. That is 7 legislative time zone changes since 1961. The state of Oregon has legislated one time zone, but observes another. So yes, Michael, time is weird as soon as you get outside of UTC.